The length of a rectangle is 3 meters greater than twice its width. The area of the rectangle is less than 55 meters. What are possible dimensions of the rectangle to the nearest tenth of a meter? So we read through our question. It's dealing with a rectangle. Often, it really helps to draw a picture. So I draw a picture of my rectangle. Labeling the sides, I don't know how big the sides are, but I know that the length is 3 meters greater than twice the width. So if I decide to make my width x, my length is 3 meters more than twice, so twice would be 2x, 3 meters more would be plus 3, and now I have a rectangle. The second sentence is it's talking about the area of a rectangle. So I might be like, oh, I know how to find area. Area is length times width. And this area has to be less than 55 meters. So now I know that this area, if I multiply it out, which is 2x squared plus 3x, it has to be less than, but not equal to 55. So now I've set up a quadratic inequality. So sometimes when we're reading a word problem like this, take it slow. It's dealing with a rectangle. I'll draw a picture. It's dealing with area. I know what my area formula is. It needs to be less than 55. So I take my time writing things out, and now it says, what are the possible dimensions of the rectangle to the nearest tenth? Well, it's a quadratic inequality. We solve quadratic inequalities by making one side equal to 0, and then we solve. And we solve this by either factoring, completing the square, or the quadratic formula. There's a hint in here that tells you maybe you should go to the quadratic formula. What's the hint in the question that factoring most likely won't work? Does anyone see the hint in the question? Yeah, not easy mental math. Whenever they're like, use a calculator and round, you're like, ooh, my mental math isn't going to be very good. So now, if those of you that have graphing calculators have an advantage here because you could use a graphing calculator to find this. If not, you could use the quadratic formula. I'm going to show you both ways, starting with the quadratic formula. And then looking at the graphing calculator. Because it would have to be a calculator question if it's to the nearest tenth. So if I'm using my quadratic formula, I want to solve for x. So x would equal negative b plus or minus the square root of b squared minus 4a and c all over 2a. And we get negative 3 plus or minus 8 times, that's 449 all over 4, which gives us two answers for x. We have one answer where we add, and we have one answer where we subtract. So if we add, to the nearest tenth would be 4.5, and if we subtract, negative 6.0. So those are our two answers from our quadratic formula. Now, first of all, okay, look at your picture. One of those answers is somewhat problematic. Why is the minus 6 a problem? You can't have a negative area. You can't have a negative side. Actually, If you were allowed to use -6, this side would be negative, and this side would be negative, and you would still get a positive area. But it doesn't make sense to have a negative side on your graph. So normally, if you had done your number line here, if you had done your number line and done -6 and 4.5, you would have found out this section, testing points, this section would be true, this section is false, and this section is false. But this doesn't really make sense. What's the probably 0 is the only true section in there. So you could either, the textbook writes it this way, the width is less than 4.5 meters. We'd have to include our units. It would also be fine to write it in interval notation, because technically less than 4.5 meters is making an assumption that a person knows it can't be negative. Because technically -7 is less than 4.5. So you could write it in interval notation or in set notation that way. Then if you plug in 4.5 for x and solve the other side, you'll get 6.1. And when you plug in the 4.5, you would have to go back to using all the decimal places. Because if you use the rounded value to calculate the 6.1, I think you'll only get 6. And then you would lose half a mark for rounding early. So careful with that. So we found the 4.5 with the quadratic formula. I'm going to show you that if you take out your graphing calculator and you type in the 2x squared plus 3x minus 55 into your graphing calculator and look at the graph, it has two x-intercepts. You have one that looks like, these are going by ones right now, one that looks like it's between 4 and 5, and one that looks like it's between -7 and -5. You can find those values by going second, and above the trace button is all of your calculations for graphs. And we want to find number 2, the x-intercepts or the zeros. Now, you have two options. You can move left and right until you see the cursor, like I have here. I can see the cursor. But sometimes you might have a point where you're like, I have no idea where my cursor is. It gives you a hint, because it tells you the x value of where your cursor's at. We need to go, I'm going to find the one on the right first. We need to be on the left side of the x-intercept and the right side of the x-intercept to find it. One thing you can do if you don't see your cursors, you can just type in a number. I am pretty certain that the number 3 is definitely to the left of that x-intercept, and when I push enter, it draws an arrow. The newer calculators draw a vertical line. Definitely 3 was to the left. Can you tell me a number to the right? 5 or 6? Either one of those would work. Again, you could use your cursor to move until you see it and move past it to the right, or you could type in a number like 6. Is my x-intercept between those two? Yes. So on the guess part, you push enter again, and here's the 4.5. 4.547. So there is our first one. We don't have to find the negative one because we already know that that doesn't exist, but we could do this again and find the negative one. Yes?
I'm curious how you got that the length was 6.1 because the book says 12.1.
Oh. Probably because I just made a mental math mistake. If we take the 4.5, do quick mental math, and double it, I think I subtracted 3 instead of added 3. That makes sense. Thank you. 12.1. On our graphing calculator, if you wanted to find the other one, you could go second, trace again, 0. And this time the left would be like something like -8 and -1. Like, it doesn't even have to be close. You can give it a wider range. As long as there's only one x-intercept in between there, when I push enter again, it will find the -6 value right away. So knowing how to use your graphing calculator can often be a lot faster to find something than a quadratic formula, if you have that available. And as you go toward the AP exam, they're going to be asking you questions where you need to be able to do these things with your graphing calculator very quickly. Okay, questions for practice on this one? Circle 8 and 13.